Hello, chemistry. Miss Aninga here, wanting to come on and help you with two-step molar conversions, because some of you asked me about them and you were kind of stumped as where to start and how to keep going with your problems, okay? So here is your mole practice number 5 worksheet. It's entitled Two-Step Molar Conversions. It starts off with giving you a mole map and an example problem. So the way that two-step molar conversions work is that you cannot go from, say, one branch of your mole map to another without first moving to moles, because moles is your intermediary or your go-to unit first. Okay? So in our first example here, it says that you are given a 40-liter canister of nitrogen, and they want to find out how many actual molecules of nitrogen gas there are in those 40 liters. Okay? And they tell us specifically it's nitrogen monoxide gas. Okay? So they do one step here going from liters to moles, but it didn't ask for moles, it asked for molecules. So they lay this all out here, but basically what they're doing is they read it and they go, where are we starting? What are we given? So we're given 40 liters of nitrogen monoxide gas. And so you find that here on your mole map, which is right here. And then you look to see where you need to go or where your problem is going to end. So if you reread your problem, it asks how many actual molecules are there in that amount of gas. This is where you want to go. So on your mole map, how it works is you have to follow your arrows from where you are to where you need to go. So notice this says you have a volume of gas, you need to go to moles. You cannot just jump from volume to atoms straight off the bat. You have to follow the arrow path. So it says that in order to go from volume to moles, we have to use this here 22.4 liter conversion factor. And when we're thinking about that conversion factor, this is saying that 1 mole of any gas at STP, or standard temperature and pressure, is 22.4 liters, or that's how much it takes up. You can write any of these conversion factors that you have here in one of two ways. Like this, where we say 22.4 liters is how much volume 1 mole takes up. Or like this, where it is 1 mole is equal to the 22.4 liters of space. Okay? So you'll notice here that they wrote down their liters like they normally do, and then they used the 22.4 moles conversion factor. They used this version right here, because in order to get rid of liters on the bottom here, we have to have liters on the bottom on that side. Okay? So you figure out which of your two conversion factors you have to use when you encounter that there. That's your first conversion. Notice that'll get you to moles, which is on top. After that, moles would go to the end as your answer, but we want molecules, okay? So you have to write another conversion factor, making sure to have moles here on the bottom because you need to get rid of moles here. Then you all have to check out how you go from moles to molecules, and it says to use 6.02 times 10 to the 24th as your conversion factor. Again, this conversion factor can be written in one of two ways, where 1 mole is 6.02 times 10 to the 23rd atoms or molecules, or the flipped around version where 6.02 times 10 to the 23rd atoms or molecules is equal to a mole. That's how you can write this conversion factor. Then all you have to do is figure out which one you need to use. According to this, with mole having to be on the bottom, that means we're going to be using this one. And so that's why they use this one here. Molecules is what would go to the end. You reread your problem and say, is that what I'm looking for? Which it is. So molecules would go to the end. That's your answer. Unit. All you have to do now is just plug in your calculation into your calculator, and that's it. So let's go to Desmos here and put this calculation in. So 4D divided by 22.4. That's this first conversion. And then in order to keep going, just either press enter or press over, and then times your 6.02 times 10 to the 23rd. And you can see we get our answer of 1.08 roughly times 10 to the 24th power molecules. Okay? I'm going to do the rest of these problems as well to show you how you do them, to give you an idea of, practicing using your mole map with your problems. Okay? So, first off, read your question. It says convert 0.75 grams of nitrogen gas, which is N2, into liters. Okay, so this is important, this seems important, and this seems important. Okay. As always, we write down what we're given first. Sorry, I'm going to scooch it closer a little bit to make it clear. So, in order to get rid of grams on top, we need to have grams on the bottom. So what I'm going to do here is going to map out my units real quick. So grams has to be here to cancel. When we look at our grams in our mole map, in order to go anywhere from grams, we had to use the molar mass. That's what formula mass is. That's just your molar mass, okay? To get to moles. So we know that we're going to moles here. So 1 mole should be on top and grams on the bottom. And then we're not done yet because it wants to know what liters are. So we went from grams, we want to go to moles, and then we want to go to liters of gas. Okay, we have to use our 22.4 conversion factor again. Okay, and we want to end with liters, right? So in order to get rid of moles, which one do we use? Yep, that's right. We use this one because we want to have 1 mole on the bottom to get rid of it. And then we'll have 22.4 liters on the bottom. Or on the top, sorry. And that will go to the end as your answer in liters. Okay. Now, all we have to do is figure out what our molar mass of N2 is, and that's easy enough. Look at your periodic table. Find nitrogen, and you'll see that nitrogen is 14 molar as a molar mass, so it's 14 grams per mole. So that's the number that goes down here. But that's normal nitrogen. You'll notice that we have N2 here, so we need to times that by 2, which of course is 28 grams. Okay. All right, we've filled everything in, and now all you got to do is solve it. So come back. You can use Desmos or any other calculator if you want to. So 0.75 divided by 28. Go over so that we can do everything all at once. Times 22.4 liters gets us the answer of 0.6 liters, which is our answer. Okay. This one is all about both following your mole map and remembering how your units get crossed off. Okay. Let's do the next one. So it says, so we read first, convert 10 grams of potassium phosphate, which is K3PO4, to molecules. Okay. So again, write down what you're given first. It's over 1. And we have to get rid of grams and go to molecules. If you look at our mole map, we're going from grams again. So grams, we have to use the molar mass to get away from grams and get to moles. And we want to get to molecules, so that's over here. So in order to go from moles to molecules, we have to use our 6.02 times 10 to the 23rd number. Okay, so let's map out those units. So grams, we got to get rid of grams, so it has to be on the bottom. And we have to go to moles. So moles is on the top, 1 mole. And then in order to go from moles to molecules, we have to use our 6.02 times 10 to the 23rd conversion factor. If we attach, it's either one of these. Which one do we use? That's right, we use this one because mole is on the bottom. And we want to get rid of these moles. So you write 6.02 times 10 to the 23rd molecules over 1 mole. Now you'll notice the only thing we have to figure out here is how heavy potassium phosphate is. And so you just have to find the molar mass. Okay, so K3PO4, you have to find the molar mass of that. So we have K, we got P, we got O, we got potassium, phosphorus, and oxygen. Find the weights of each of those, looking at your periodic table. K is over here. It is, I'm going to round that to 39.1 grams. Then we got oxygen, which of course is 16. And phosphorus, which is, I'm going to round that to 31. Okay. And just figure out how many of each there are. There's 3 potassiums, there's only 1 phosphorus, and there are 4 oxygens. So times those by their amounts. 39.1 times 3 is 117.3. 31 times 1 is, of course, 31. And 16 times 4 is 64. Add those all up. 17.3 plus 31 plus 64 is a total of 212.3 grams. So that's our molar mass. So that's what we place in here, in our equation, in our problem right here. So 212.3. If you rounded to 212, that's perfectly fine. Okay. Make sure your units will cancel out. Grams to grams and moles to moles, leaving molecules to go to the end. So now that you're finding what you need according to your problem, just go back into your calculator and solve. So we got 10 grams divided by 212.3. Click over so we can do our big number. Oh, sorry. Times 6.02 times 10 to the 23rd. Close brackets. And that'll get us our amount in molecules. And as you can see, we expected a big number, which is good. So we have our total, which is 2.84 times 10 to the 22nd power molecules. Again, making sure that our units end up in a place where they can cancel, and that our final unit is not only present but on top, so that it ends up on the top of the equation at the end as you're on top for your answer. All right, last one. Convert 1.00 times 10 to the 24th molecules of carbon dioxide into liters. So molecules is important, liters is important. Let's double check to see if carbon dioxide is important. It sounds important, but we'll see if it is important. Okay. We write down what we are given first, which is 1.00 times 10 to the 24th molecules of carbon dioxide. Okay. After that, we check where we are on our mole map. We start off here. And it says it wants us to get to liters, which is down here. So we start here. And we want to get here. So we need to move from atoms to moles, and then from moles to liters. We need to use these two conversion factors. Our first one can be written in one of two ways. If we look at our problem, molecules is on top. So in order to get rid of it, which one of these are we going to be using? And it's going to be this one, because we want molecules to cancel out being on the bottom. So we write that down. 1 mole is 6.02 times 10 to the 23rd molecules. So that's our first conversion factor. And then we still need to get to liters. So we need to go from moles to liters by using our 22.4 moles of liters per mole. This conversion factor can be written in those two ways. We look at where it needs to go, which is in our next area. So which one do we need to use so that our moles cancel out and our liters go to the end? It's going to be this one, because we want moles down here to cancel out. So we write down this one right here. So 22.4 liters to 1 mole. Double check your units. Molecules cancel out here and here, and mole here and here, leaving us liters to go to the end. Okay. Now that we've answered what we need to and filled in all of our blanks, now all you have to do is again go through and solve everything. So let me go do that here. Oops. So we have 1.00 times 10 to the 24th molecules. We're dividing that by our 6.02 times 10 to the 23rd molecules. Press over so that we're just getting rid of those. And now times by 22.4 to get our answer, which is 37.2 liters. Okay. Hopefully this helps with two-step conversions. As a summary, remember, just read your question, see what you have and where you need to go, and look at your mole map to figure out what conversion factors that you need to use. So if you're going from molecules to grams, you need to follow these two conversion factors. If you're going from atoms to volume, you again follow the two conversion factors that are on the lines. If you're going from volume to grams, these two. And if you're having a hard time trying to figure out which conversion factor types you use, if you want to do what I did and write them out for yourself, you can even line up these post-it notes in a way to make it easier for you. Like I have post-it notes for all my conversion factors, not just my my volume ones and my molecule atom ones, but I also have the molar mass ones here that you could fill in the blanks if you need to. And so you can, line them up if you need to. For example, the convert 0.75 grams and you need to get 2 liters at the end. So So you figure out which ones you need. You don't need these because we're not going to molecules. We'll need these because we're going to liters. We'll need this one because we're talking about grams. So you just take that and you figure out which one you need. Is it this one or this one? You can say it and you can see that it's that one. Don't need those ones, sorry. And then you can put this one here, see if it looks right. We'll put that one there and see if it looks right. Should be this one because mole and mole. Okay? And then you can solve for the end. Alright? Alright, another long video, but that's okay. Helps you out, I hope. If not, please let me know if you have any more questions and I'd be happy to help. Okay? Alright, chemistry, I'll talk to you later. Good luck on the two-step conversions. Remember, this is like one of the last ones. It's just this one and number 6, and then we're done with mole conversions. Okay? So please, 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 if you have questions now, ask now rather than later, because practice makes this easier. Okay? All right. See you later, chemistry.